14. Identify the complex conjugates of the following complex numbers. So the fast way of doing that is swapping the signs, but keeping the real the same. So we get 4 plus 5i, negative 6 minus 2i, and a positive 4i. 15. Perform the indicated operations involving complex numbers. Write your answers in the standard form. Or the standard form is A plus BI. So 2 minus 5i times 3 plus 4i. Foil that out. We get 6 plus 8i minus 15i minus 20i squared. Start simplifying, we get 6 minus 7i minus 20 times a negative 1 from the I squared. So we'll get 26 minus 7i. 7 plus 6i plus negative 4 minus 3i. Combine the real parts, so we get 3, and then not negative, 6 minus 3 is 3, so plus 3i. Negative 3 plus 4i minus negative 7 minus 2i. You distribute that negative to both sides. So we'll get negative 3 plus 7, so we should get 4. Then we'll get 4i plus 2i, which should be 6i. So 6 minus 5i over 3 plus 2i, so we need to multiply by the complex conjugate of the denominator, both top and bottom. So when we do that on top, we should get 18 minus 15i minus 12i plus 10i squared over 9 minus 6i plus 6i minus 4i squared. So I squareds are going to become negative 1, so on top when we simplify we should get 8 minus 27i, and then on bottom we get 9 plus 4. So we'll get 8 over 13 plus minus 27 over 13i. 16, solve the quadratic equation 3x squared plus x minus 10 equals 0 by factoring and applying the zero product property. Minus 10 equals 0. So you can immediately factor if you see what it is. For those who don't, you usually look at factors of the 3 and the 10. So factors of the 3 would be 1 and 3. Factors of 10, 1 and 10, 2 and 5. So then we can set up, we can go 3x for one of them and x for the other one, since there's the only two factors. Since this is a negative 10, that means these two are of opposite signs, and then we need to find some combination, and whenever we FOIL it all back out, it adds up to 1. So with that, we're going to say minus 5 plus 3 plus 2, sorry, plus 2. And then if we FOIL that out, we'll get 3x squared minus 5x plus 6x minus 10. We do in fact get back to the original. So the zero product property then states we can say 3x minus 5 is equal to 0 and x plus 2 is equal to 0, and that solves to x is equal to 5/3 and x is equal to negative 2. 17, solve the quadratic equation 2x minus 3 quantity squared equals 24 using the square root property. So 2x minus 3 quantity squared is equal to 24. So we take the square root of both sides. Since we introduced the square root, we'll look at the plus and minus values of that. We'll continue on with the positive case. Is equal to 24 plus 3. X is equal to root 24 plus 3 over 2. The only other thing that we could do is simplify that square root, which we can pull a 4 out of. So that would be the positive case. We look at the negative case. It'll follow a similar solution path. And this time we would just get a negative in front of the square root. Alright, solve the following quadratic equations by completing the square and then simplify. So x squared plus 6x plus 14 equals 0. So the first step in completing the square, plus 3 quantity squared, but in doing this, we have actually added that value squared, so we need to immediately subtract it. So x plus 3 squared, 14 minus 9 is positive 5 equal to 0. We get x plus 3 quantity squared is equal to negative 5. X plus 3 is equal to plus or minus the square root of negative 5. X is equal to plus or minus root 5i minus 3. And then putting it in a more acceptable form, negative 3 plus or minus I root 5. 3x squared minus 18x plus 24 is equal to 0. First thing with completing the square, we want this value to be implied 1, so we need to factor out or divide everything by 3. Equal to 0, that should be a squared. So then we get x squared minus 6x plus 8 is equal to 0. X minus 3 squared. With that, we added 9 plus 8 is equal to 0. X minus 3 squared minus 1 is equal to 0. X minus 3 quantity squared is equal to 1. X minus 3 is equal to plus or minus the square root of 1, which is 1. So we get that we get 3 plus or minus 1, or x is equal to 2 and 4. There, x squared plus 10x minus 15 is equal to 0. We already have that implied 1, So we get x plus 5 quantity squared. When we did that, we actually added 25, so we need to subtract 25. $40 is equal to positive 40. We get x is equal to plus or minus 2 root 10 minus 5. Write that as negative 5 plus or minus 2 times the square root of 10. Solve the following quadratic equations using the quadratic formula and simplify. So 2x squared plus 4x minus 5 is equal to 0. So it's already set up for us. This is a, b, and our c value. So the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And if we plug our values in, we get negative 4 plus or minus the square root of 4 squared minus 4 times our a, which is 2, times our c, which is negative 5, all over 2 times 2. So plug some of that into our calculator. We can get 56 under the square root over 4. And then this will simplify to negative 1 plus or minus 1/2 square root 14. 5x squared minus 6x plus 7 is equal to 0. Same process, so it will be negative b, so in this case 6, plus or minus b squared, and so negative 6 squared, minus 4 times our a times c, which is 5 and 7 respectively, over 2 times 5. So this will be 6 plus or minus the square root of negative 104 over 10. Upon further simplification, we can get 6 plus or minus 2i root 26 over 10. And then if we put that in a plus bi form, we'll get 3/5 plus or minus 1 or root 26 over 5i. Alright, 20, find the discriminant, then determine the number and types of solutions for the following quadratic equations. So the discriminant, we go back to the negative b plus or minus square root of b squared minus 4ac all over 2a. The discriminant is everything under the square root. So it would be this b squared minus 4ac is the discriminant. So in this case, the discriminant will be negative 5 squared minus 4 times 6 times 3. And when we put that in our calculator, we get negative 47. So with that, we get 2 complex slash not real values. And this one is 2x squared plus 3x equal to 5, so we need to have some setup. Is is equal to 0. Now we can find the discriminant, which would be 3 squared minus 4 times 2 times -5. And when we put that into our calculator, we should get 49. This indicates 2 real solutions.
Okay, 21. We're going to solve the quadratic equation. -16t squared plus v naught t plus s naught equals 0 for t. And we're going to simplify. So I think the easiest approach is just going to be take everything and plug it into the quadratic equation. So in this equation, I know that a is equal to -16, b is equal to v naught, and c is equal to s naught. So now I just have to plug it into my quadratic equation, which is -b plus or minus the square root b squared minus 4ac all over 2a. So if I plug all this in, I get t equals -v naught plus or minus the square root of v naught squared minus, so I have 4 times a times c. So this is going to become plus 4 times 16 is 64, and then c, which is s naught. So you can just leave it as that, and then divided by 2a, which is -32. So this is about as simplified as we can get. The only other thing that we can maybe do is technically pull out a negative from this and go ahead and make it all positive. However, this would remain as plus or minus if we pull out a negative from it. So we can go ahead and write that as well, that t can equal v naught plus or minus the square root of v naught squared plus 64 s naught over 32. There's not really anything else we can do. So this will be our final answer. Okay, 22. We have a patio, which is configured from a rectangle with 2 right triangles of equal size attached at the 2 shorter ends. The length of the rectangle is 30 feet. The base of each triangle is 3 feet less than the height of each triangle. If the total area of the patio is 468 feet squared, determine the height and base of the triangular portions, answer the complete sentence, and show all work. So let's try drawing what we're imagining here. So we know that there's going to be a rectangular portion, which might look something like this. And we know that the length of this rectangle is 30 feet. And we also know that at the shorter ends of the rectangle, there's 2 right triangles of equal size. So maybe something like this here. Sorry, I'm not the best artist. So there we go. So we also know that the area of this whole thing is going to be 468 feet squared. And that the base of each right triangle is 3 feet less than the height. So I'm going to write that the base of each of these is our height minus 3. So each one of these triangles has a B and an H here. So now let's try writing an equation for the area of this whole shape, because we know it's going to be 468. So this whole area is going to be the rectangular portion, which is 30, times our height. So here we have just this here times this, which gives us just this rectangular area. Now we have 2 triangles, and they're of equal area. So we have plus 2 triangles, and then the formula for the area of a triangle is 1/2 base times height. So we can see that this 2 and this 1/2 here are going to cancel out. So we end up with 468 equals 30h plus bh. Now we also know that b is equal to h minus 3, so we can actually just substitute it in right there. Get 468 equals 30h plus h times h minus 3. And again, all I did is I just took this here and I put it right here for b. So now if I simplify this sum, you get 468 equals 30h plus h squared minus 3h. Now let's combine like terms and get everything to one side. So I have h squared plus 27h minus 468. So from here, we can take this and plug it in to the quadratic equation to solve for h. So I know h is going to equal negative b, so negative 27, plus or minus the square root of 27 squared, minus 4ac, so that's going to be plus 4 times 1 times 468. And I went ahead and just pulled that negative out right away. And then we also have this whole thing divided by 2a, or just 2. So now if I use my calculator here, I can go ahead and type this and plug that in, and I'll find out that h is going to be equal to negative 27 plus or minus 51 divided by 2. So this gives me two different answers for h, but only one of them can be right, because we only have one sized rectangle here. So the one that's going to be right is going to be the one that's positive, because if I had negative 27 minus 51, we're going to have some negative height, which we really don't want. So let's use the positive version of 51, in which case we'll get that h is going to be equal to 12. Now from here, I know that my base is equal to h minus 3, so 12 minus 3, or that my base is equal to 9 feet. So going back, I know the height of the triangle, or of the triangular portion, is 12 feet. My unit's down here. And the base is, and the base is 9 feet. And we're done. Okay, 23. For a certain stretch of road, the stopping distance of a vehicle is determined by distance equals 0.044 v squared plus 1.1 v, where d represents the stopping distance in feet and v represents the speed in miles per hour before the brakes are applied. With this information, find the following. A. Determine the distance to nearest foot that it would take a car traveling 60 miles per hour to stop. Answer with a complete sentence and show all work. So the stopping distance is given by this equation. So what we're solving for here is d of v, which is equal to 0.044 v squared plus 1.1 v. We're asked to find what is the stopping distance if v is equal to 60. So all we have to do is wherever there is a v, we can plug in 60 and type this into our calculator. So if I type this into my calculator, I should get that distance is about 225 feet. So if the car on this road is traveling 60 miles per hour, it would take 225 feet to come to a complete stop. Okay, now for B, up to what speed is the nearest mile per hour could a car traveling and stop in 300 feet? Answer in a complete sentence. So this time, we have that our distance is 300 and we're solving for velocity. So the first thing that we're going to do is move everything to one side of the equation. Now we can take this and plug it into the quadratic equation. So I have that v is going to equal negative 1.1 plus or minus the square root of 1.1 squared minus 4 times a times c, all divided by 2 times a. So if I go ahead and solve this out and take the positive answer, I get that our velocity should be approximately 71, and our units for velocity are in miles per hour, so mph. So as long as we're going below 71 miles per hour, we can stop within 300 feet. Okay, 24, solve the polynomial equation using the zero product property. So anytime that I start with a polynomial and there's 4 different terms, generally a good first idea is to try and break it up, kind of like this, and try and solve it using factoring by grouping. It's generally a good first approach. So if I break this up to 25 y cubed plus 100 y squared, and then minus y minus 4, and sort of section these off, set this equal to 0. Let's first start with this here. Let's think of the largest thing that we're able to pull out of both those first 2 terms. Well, I can pull out a 25 y squared. And what will I have left? I'll have a y left here, and then a 4 left here. So now I need to pull something out of this, so that way I end up with y plus 4 here. You can see that if I pull out a negative 1, I'll have a y plus 4 left over. So now because this term and this term have a y plus 4 in them, I can pull both those out, and I'll have y plus 4 times 25 y squared minus 1 equals 0. So now we apply the zero product property, and we set each one of these individually equal to 0. Oops. So this first one is going to give me that y is equal to negative 4. And the second equation, I'm going to have y squared equals 1 over 25. And if I take the square root of that, I get that y is going to equal plus or minus 1 over 5. So that means my answers are going to be y is going to equal negative 4, negative 1/5, and positive 1/5. Okay, number 25, solve the rational equation. So I have 3x over x minus 5 minus 2 over x plus 1 equals 2x squared plus 40 over x squared minus 4x minus 5. So the first thing that I'm going to do is on this side, it's probably a good idea to get a common denominator between these two. And on this side, it's probably a good idea to try and factor this just to see how this x squared minus 4x minus 5 was made. So on the right side, I'm going to multiply the first term by x plus 1 over x plus 1 into 3x over x minus 5. And then on the second one, I'm going to multiply by x minus 5 over x minus 5 times 2 over x plus 1. And I went ahead and pulled this negative from here out to there. And again, the reason why we're multiplying by this here is that way both of these, our denominators, are the same. But I can't just multiply just the denominator by x plus 1. I have to multiply by x plus 1 over x plus 1. So that way, we're not fundamentally changing anything. We're just multiplying by 1. So this is going to be equal to 2x squared plus 40. Oops. Well, here, let's just go ahead and leave that there and say that this is equal to 2x squared plus 40 over, so now if I'm going to factor this, I need to think of two numbers that multiply to -5 and add to -4. So the two that I can think of is 5 and 1, and I'm going to make the 5 negative, so that way I get to -4 if I add the two. So I have x minus 5 and x plus 1, okay. Which is nice because this here is the exact same as this here. So now I'm going to write everything all together. So on my left side, I'm going to have 3x times x plus 1 minus 2 times x minus 5 all over x minus 5 times x plus 1. This is going to be equal to 2x squared plus 40 over x minus 5 times x plus 1. So now I can go ahead and, so because these have the same denominator, I can go ahead and just add the tops, or the numerators. That's what I did here. And now, because all of this has the same denominator, what I'm going to do is multiply everything by x minus 5 and x plus 1, which will allow me to cancel out all of this here. So we'll cancel this out with this out, basically. But in the process of doing that, I have to make a little note, because whenever I have these here in our denominator, we get something. We get that x cannot equal 5 and x cannot equal -1. Because if I was to plug in -1 or 5 back in up here or here or here, I would end up getting a divide by 0 error. So because I've sort of canceled them out, I want to go ahead and make a note that x cannot equal 5 and x cannot equal -1. But from here, I can go ahead and continue just from looking at the numerator. So I have 3x squared plus 3x minus 2x plus 10 equals 2x squared plus 40. So now I'm going to get everything to one side of my equation. So I'm going to have x squared plus x minus 30 equals 0. So from here, I need to think of two numbers that multiply to -30 and add to 1. So my two numbers are going to be x plus 6 times x minus 5 equals 0. So now from the zero product property, I get that x is going to equal -6 and +5. But remember, we said earlier that x cannot equal 5, because if I plug that into my original equation, I get a divide by 0 error. So the only answer is going to be that x equals -6.
Okay, looking at question 26a here, we have the square root of 2x minus 3 is equal to 7, and we want to solve this equation for x. First thing we need to do is get rid of this radical, or the square root, and to do that we have to square both sides. So we're going to take this, square both sides, and then it's going to get rid of this on our left-hand side, so we're going to put 2x minus 3, and 7 squared is going to leave us with 49. Now what we want to do is get like terms on one side, so we're going to add 3. Leaves with 2x is equal to 52. Now dividing both sides by 2, we know that x is equal to 26. So we're here, remember x is equal to 26. Now looking at our next part, we have the square root of y plus 18 plus 2 is equal to y. So what we want to do is solve for y here. So first thing I'm going to do is subtract 2 on both sides, just so we can get that radical by itself. 18 is equal to y minus 2. So now, like we did in the previous part, we want to square both sides to get rid of that square root. And whenever we're squaring both sides, we're squaring that y minus 2 at the same time, because it's the same. So we're going to be left with y plus 18 on this side, and then y minus 2 squared on this side. So next what we want to do is FOIL out our y minus 2. So we really want to rewrite this left-hand side as y minus 2 times y minus 2, and FOIL it out doing our first term, our outer term, our inner term, and our last term, right? So we bring that y plus 18 down. So our first term is going to leave us with a y squared. Our outer term is going to leave us with a minus 2y. And then our inner term, minus 2y. And our last term is going to leave us with a plus 4. Now condensing our right-hand side and putting like terms together, we're going to have y squared. These minus 2's are going to come together for minus 4y plus 4. Now we want to move everything onto one side, all the like terms, and create a quadratic for ourselves. So minus y, and then minus 18, right? So our left-hand side is going to be left with 0 is equal to y squared minus 5y. And then, I don't know why that went to red, 5y. And then we're going to have 4 minus 18, which should leave us with a minus 14. So now we need to think of two terms that multiply to give us negative 14 and add up to give us negative 5. My first thought whenever what multiplies to give us negative 14 is going to be negative 5 positive 7. Right? I'm sorry, not negative 5. Negative 2 positive 7. But those are not going to add up to give us the correct number. So we're going to think about negative 7 positive 2, right? That's going to give us that negative 14. Negative 7 plus 2 is going to give us that negative 5. So we're going to have y minus 7, y plus 2. It's equal to 0. So we want to set both of them equal to 0. Y minus 7, 0 equal to y plus 2. That's going to make y equal to 7 and y equal to negative 2. Okay, now looking at number 26, part C here. We're given the square root of n plus 4 minus the square root of 6 plus 2n is equal to negative 1. So just like on our previous ones, we're going to have to square both sides. This one's going to get a little tricky, but we're going to do great on it. Square both sides. So our right side is going to end up going to 1, right? Because a negative square is just going to be positive. Our right side, we're going to have square root of n plus 4 minus the square root of 6 plus 2n, and all that times itself. So times the square root of n plus 4 minus the square root of 6 plus 2n. Now what we're going to do is we're going to FOIL this out. Our first term, square root of n plus 4 times square root of n plus 4. Since it's the same term inside being multiplied, we're going to have n plus 4. Our outer term is what's going to get tricky here. So let's do our last term first. Minus square root of 6 plus 2n times minus square root of 6 plus 2n. So there's a plus 6 plus 2n. But now what we're going to be left with, for our inner and outer functions, we're going to have minus the square root. And what's happening here is both interiors are being multiplied together. n plus 4 times 6 plus 2n. We're actually going to have 2 of those. So minus the same thing. What I'm going to end up doing is, since we have 2 of them, I'm just going to write a 2 out front. I'm going to say that we have minus 2. 2 times all of that is equal to 1. So now to deal with our interior here, I'm going to combine our like terms on our outside. So we're going to have 3n plus 10 minus 2 times the square root. We're going to FOIL out our interior of this now. So 6n plus 2n squared plus 24 plus, and then last plus 8n is equal to 1. Now combining our like terms inside, we're going to have that 3n plus 10 minus 2 times the square root. Now we're going to have 2n squared. 8n plus 6n is going to leave us with 14n plus 24. Now that's equal to 1. Now what we're going to do is move this 3n and this 10 onto our right hand side. So now we're going to be left with minus, that should be minus 2 times the square root of 2n squared plus 14n plus 24. It's going to be equal to minus 3n minus 9. All right, now what we want to do is get rid of this radical for good now. So we're going to square everything again. So our left-hand side, we're going to be left with, so this negative 2 squared is going to be left with 4 times what we have on our interior here. So 2n squared, that squared is going to take care of a radical. 2n squared plus 14n plus 24. Now what we're doing here is we're flowing out 3n minus 9. Negative 3n minus 9. So I'm going to do that over on this left-hand side. So minus 3n minus 9 times minus 3n minus 9. First term, we're going to have negative 3n times negative 3n, so 9n squared. Our last term's negative 3n minus 9n, minus 9, so plus 27n. Inner, we're also going to have another plus 27n, and last, we're going to have a plus 81, right? Simplifying that and our 27s together, so 27 plus 27 is going to give us with 54, so n squared, 9n squared plus 54n plus 81 is what that negative 3n minus 9 is going to give us. Write that up here. 9n squared plus 54n plus 81. I'm going to erase all this real quick. So now what we're going to do is start simplifying a little bit. Distribute out our 4. So we're going to have 8n squared plus 14 times 4 is going to leave us with 56n, and then 24 times 4 is going to give us 96, so plus 96 is equal to 9n squared plus 54n plus 81. Now to get our quadratic, we're going to move everything onto one side. I'm going to move everything on our left side onto our right side. So minus 8n squared minus 56n minus 96. And then minus 8n squared minus 56n minus 96. So we're going to have 0 is equal to 9n squared minus 8n squared. It's going to leave us with 1n squared. 54n minus 56n is going to leave us with minus 2n. And then 81 minus 96 is going to leave us with minus 15. So now we got to think about what two numbers are going to factor out to give us, or multiply to give us negative 15 and add up to give us negative 2. Look just at that 15 and think what two numbers are going to multiply to give us 15. Two numbers are going to be 15 and 1 or 5 and 3. Most likely it's going to be the 5 and 3 because of the 2. So we got to think, okay, what's going to add up to give us negative 2 and multiply to give us negative 15? So it's going to be our n minus 5 and n plus 3. So typically whenever you see a negative here and a negative here, right, this negative is going to come from our larger number being negative and our smaller one being positive. It's kind of what we have to think there. And that's equal to 0. So we know that n is going to be 5 and n is going to be equal to negative 3. Okay, now looking at question 27, part A here. First, we want to solve the following equation with rational exponents. So our equation is 2x minus 1 to the power of 3 halves minus 3 is equal to 122. First thing I'm going to do is add this 3 on both sides. So we're going to have 2x minus 1 power of 3 halves is equal to 125. So now we need to get rid of this power of 3 halves, and to do that we need to take it to the power of its in, something that's going to get rid of it. So in this case we want to take it to the power of 2 thirds. I'm going to take this 125 to the power of 2 thirds as well. So our left-hand side, we're going to have 2x minus 1, and we'll have 125 to the power of 2 thirds over here. Another way we can write this is either 125 to the power of 2, and that's to the power of 1/3. So we'd be squaring that and taking it to the power of 1/3, or we could also write it as 125 to the 1/3 to the power of 2. It's going to give us the same thing. So 125 to the power of 1/3, and take that to the power of 2. It's going to give us 25. Same thing, let's try it again the other way. 125 to the power of 2. And now we're going to take that to the power of 1/3. Also going to give us 25, right? So now we're going to have 2x minus 1 is equal to 25. Add 1 on both sides. 2x is equal to 26. Now we're going to divide both sides by 2, and we'll have x is equal to 13. Okay, now we look at part B here. We have 2 times d minus 5 power of 2 thirds is equal to 18. That's something on the screen. Okay, first thing I'm going to do is divide both sides by 2, just to get rid of that extra little bit that we have there. So we have d minus 5. Let me rewrite that cleaner. D minus 5 to the power of 2 thirds is equal to 18 over 2 is 9. So just like we did in the last one, we want to take it to the inverse of what we just have. So take it to the power of 3 halves this time. So that's going to get rid of that. So we're going to have d minus 5 on our left-hand side and 9 to the 3 halves on our right, which we could also write as 9 to the power of 3 to the power of 1/2. If we do that calculation real quick, 9 to the power of 3 is going to give us 729, and that to the power of 1/2 is going to give us 27. So we're going to have d minus 5 is equal to 27. Now to solve for d, we're going to add 5 on both sides. 27 plus 5 is going to leave us with 32.